Hi, my name is Richard and welcome to my channel. Today our discussion in mathematics will be on circle theorems. People refer to circle theorems as plane geometry 2 in a sense that before you understand circle theory very well, the idea behind it is that you might have done plane geometry 1. So in plane geometry 1, we look at alternating angles, corresponding angles, vertically opposite angles, angles at a point. Remember, angles at a point add up to 360 degrees. Angles on a straight line, and also remember, angles on a straight line add up to 180 degrees. Then the sum of interior angles of a triangle. The sum of interior angle of a triangle is 180 degrees, and the sum of interior angle of other polygons. So please, this is plane geometry 1. You might have heard this idea very well before you understand circle theorem or plane geometry 2. So today, before the video ends, I will introduce you to some parts of a circle, since they may play a very major part in our understanding of this topic. So we'll look at some parts of a circle, then we'll look at some properties governing circles. With that property, we can be able to solve questions or problems governing circle theory. There are a lot of properties, but today we'll look at 4 of them. Then check out my videos where we'll talk about the other properties. This will be a very interesting engagement, so I indulge you to take a seat. So the first thing we'll talk about is some parts of a circle. So if we have a circle like this, okay, and we have the center, okay, any line drawn to divide the circle into 2 equal halves, or any line drawn to pass through the center of the circle and divide the circle into 2 equal halves, that line is called diameter. Take a very good notice of it. It's called diameter. Now, any line drawn from the center of the circle to the circumference, this is the distance around the circle, is called circumference. Circumference. So any line drawn from the center of the circle to any part of the circumference of a circle is called radius. And 2 radius makes 1 diameter, or diameter divided by 2 is the radius. Please, very, very necessary. Now, if I draw any line from here to this place too, is radius. So the plural form of radius is radii. So we have 2 radii. Now the area sustained by 2 radii is called sector. Sector. It's very necessary. It's called sector. Now, any line drawn to touch the circumference, the 2 parts of the circumference of a circle, but does not cut it. That line is called chord. Please, the chord will play a very major part in our lesson today. So please take notice of it. Any line drawn to join the 2 parts of the circumference of a circle, but does not cut a circle, is known as chord. Now, the area sustained by any chord, okay, the area sustained by any chord and the circumference of a circle or an arc, that is called segment. Segment. Very, very necessary. One more. If I have a circle like this and the circle is divided into 4 equal halves, okay, each half there is called quadrant. Quadrant. Please, these are basic parts of a circle that we must take notice of. Now, we'll be using this very often. Segment, chord, diameter. We are going to use them very, very often in this our understanding of circle theory. So take a very good notice of it. Now, before you can solve problems covering circle theory, then you must know the properties that govern circle theory. There are some properties, about 8 properties governing circle theory. Today, we'll look at 4 of them and their applications. So now let's look at the first property governing circle theory, or the first property of circle. Now, the first property is saying that if we have a circle and there is a chord, okay, and that chord sustains an angle at the circumference of the circle, but the same chord again sustain an angle at the same area of the segment of the circle. Those angles that the chord sustain, those angles are equal. So we can say A is equal to B. Please take notice of it. If a chord sustain an angle at the circumference of the circle, that's at the same area of a segment, then those angles are equal. So if I have a circle like this, okay, and I have a chord, that chord sustain an angle of 20 degrees here. The same chord sustain an angle here are known to be x. X is equal to 20 degrees. As far as the same chord is the one sustaining the angle at the circumference of the circle, those angles are equal. So look at it. If I have a circle like this, and I have this, and I have this, okay, and this is maybe 60 degrees. It is not drawn to scale though, and this is S. Someone will say, where is the chord? There is a chord here. Look at it. We can have a chord. So the chord there sustain an angle at the circumference of the circle. The same chord at the same area of the circle. Then those angles will be equal. So you can say S is equal to 60 degrees. I hope you get this property well. We'll look at the next property. So now let's look at the second property. So the second property is saying that if we have a circle, we are still on chord, and this is a center of a circle, let's say O, and we have a chord, okay, and the chord sustain an angle at the circumference of the circle, and the same chord sustain an angle at the center of the circle. So we have an angle here, let's say call it A, and an angle here, call it B, okay. It's saying that twice of the angle at the circumference of the circle is equal to the angle at the center. So we say 2A will be equal to B. Very, very, very necessary. So when a chord sustain an angle at the center of the circle, the same chord again sustain an angle at the circumference of the circle, those angles are equal. So we can have a problem like this, okay? This, and let's say O is the center. And I have this to be 60 degrees. And I'm asked to find the angle X. Look at it. There is no chord drawn here, but you can have a chord here. So a chord sustaining an angle at the what? Center of the circle. The same chord sustaining an angle at the circumference of the circle. Twice of the angle at the circumference of the circle is equal to the angle at the center. So we say 2 times 60 will be equal to X. So S will be equal to 120 degrees. The same way, if I have a problem like this, look at it. So, and I have this angle here to be, let's say, 80 degrees. It's not drawn to scale. And here to be Y, and I'm asked to find Y. Look at it. We say there is a chord, a hidden chord. So a chord sustain an angle at the center of the circle. The same chord again, sustain an angle at the circumference of the circle. Twice of the angle at the circumference is equal to the angle at the center. So we say 2Y will be equal to 80 degrees. When we divide both sides by 2, Y is nothing but what? 40 degrees. I hope you get that. So this is the second property. We'll look at the third one. So now let's look at the third property, still on chord. So if we have a circle and we have a chord, okay? A chord. You know what is chord by now. And the chord sustain an angle at the opposite side of the segment of the circle, like this. Okay? So we sustain an angle at the opposite side of the segment of the circle. Look at it. The same chord sustain an angle here. The two opposite sides of the circumference of the circle. Then the sum of those angles is equal to 180 degrees. So say A plus B will be equal to 180. Please take notice of it. So if I have a problem like this, and I have this, and this place is given to be maybe 120 degrees, not drawn to scale, and this is x, and I'm asked to find x. Look at it, there is a chord here, a hidden chord, and the chord sustain an angle the circumference, the two opposite sides of a segment of a circle. Then the sum of those angles are equal. So we say x plus 120 will be equal to 180. So x will be equal to 180 minus 120. So our s will be nothing but what? 60 degrees. I hope you get that. We look at the fourth property, then we try to combine all. So the property 4 is about diameter. Enough of the chord. Let's look at diameter. Remember we said that any line draw, okay, to pass through the center of the circle and divide the circle into two equal halves. That line is called diameter. Now the fourth property is saying that if a diameter sustain an angle at the circumference of the circle, that angle is nothing but 90 degrees. It's 90 degrees. So a diameter here sustain an angle at the circumference of the circle. The angle is 90 degrees. Please, let's take a very good notice of it. Now if I have a circle like this, and let's say we have a center O, and have a diameter, and that diameter sustain an angle here, and here let's say it's 30 degrees, and this place is x, and we are asked to find x. How do we find x? Remember, the property is saying that when a diameter sustain an angle at the circumference of the circle, the angle is 90 degrees. So this is a triangle. Let's say ABC is a triangle. Now the sum of interior angle from plane geometry 1, the sum of interior angle of a triangle is equal to 180 degrees. So we can say 30 plus 90 plus s will be equal to 180 degrees. 30 plus 90 will be 120 plus s will be equal to 180 degrees. So s will be equal to 180 minus 120. S is 60 degrees. I hope you get these properties. Now we'll take a sample question where we can combine 2 or 3 properties to solve a problem. And with our knowledge in plane geometry 1, we'll be able to do that. Okay, so let's solve our first question. They say O is the center of the circle PQRS. Find the value of the angle marked S and Q in this diagram. So now let's see how we solve it. We'll use the properties in solve. Always find out the property in the equation, the property that are involved in a particular problem. Then you can be able to solve it. And with your idea on plane geometry 1. Now first, we need to look for a chord. See, this is a chord. So a chord sustain an angle at the center of the circle. That same chord sustain an angle at the circumference of the circle. You remember that property. A chord sustain an angle at the two opposite sides of the circumference of a circle, or at the two opposite sides of a segment. Remember that property too. Now in plane geometry 1, we say angles at a point add up to 360 degrees. Angles at a point add up to 360 degrees. So we can find the angle here. That's angle POR. So we say that angle POR plus the angle here 220 degrees will be equal to 360. So we say angle POR plus 220 degrees will be equal to 360 degrees. So angle POR will be equal to 360 degrees minus 220. Angle POR will be equal to 140 degrees. So we're able to calculate the angle here to be 140 degrees. And remember we said when a chord sustain an angle at the center of the circle, and the same chord sustain an angle at the circumference of the circle. Twice of the angle at the circumference is equal to the angle at the center. So we can say 2 times of angle PQR, 2 times of angle PQR will be equal to which angle? Angle POR, which we found. So it will be equal to angle POR. So, what's our angle PQR? Angle PQR is Q. So Q will be equal to angle POR is 140. So 140 degrees. Now we can find Q by dividing both sides by 2. So our Q will be equal to 140 divided by 2 is 70 degrees. So the angle marked Q here will be 70 degrees. Now remember, there is another property that says that when a chord sustains an angle at the 2 opposite sides of a segment, the sum of those angles are equal. So we can say our angle, the sum of those angles are equal to 180 degrees. Please, the sum of those angles are equal to 180 degrees. So we can say angle PSR plus angle PQR will be equal to 180 degrees. What's angle PSR? Angle PSR is X. So X plus. What's angle PQR? This angle PQR is Q. And the Q, so Q will be equal to 180 degrees. S plus what's angle Q is 70 will be equal to 180 degrees. So S will be equal to 180 degrees minus 70. So our S is nothing but 110 degrees. So our P, we can say our Q is equal to 70 degrees and S is equal to 110 degrees. I hope you get that. So this is how we combine the property in solving problems. We'll look at the next problem by using the properties we have learned today to solve it. So let's look at our second example. They say in the diagram, this diagram, P, Q, R, and S. So P, Q, R, and S are points on a circle. Angle QPR is 48 degrees. So let's check angle QPR is 48 degrees true. And angle PSQ. Okay, angle PSQ here is 35 is true. And angle PRS is 31 degrees. And we have to calculate angle PQR and angle QRS. So the angle they are asking us to calculate, let's try to locate them. Angle PQR. So PQR. They are asking us to calculate the angle here. Then angle QRS. They are asking us to calculate this very angle too. Now how do we do that? We have to use the property. Look at it. See, this is a chord. PS is a chord. The chord. Okay, let's take this chord PQ is a chord. The chord, this chord, sustain an angle at the circumference of the circle. The same chord again, look at it, the same chord again, sustain an angle at the circumference. And they are in the same side of a segment of a circle. Those angles must be equal. So we say the angle here must be equal to the angle here. So that's one property. So we say angle PSR. So that's the 35. Angle PSR will be equal to angle QRS. I hope you get that. This angle QRP. This angle. It will be equal to angle QRP. So it will be equal to angle QRP. And they are all equal to 35 degrees. So we can say our angle QRP is equal to 35 degrees. So the angle here is 35 degrees. Now, look, they are asking us to find angle PQR, this angle here. Let's take triangle PQR. Triangle PQR PQR is a triangle without any doubt. The sum of the interior angle of that triangle will be equal to 180 degrees. So the angle here plus the angle here plus the angle here will be equal to 180. So we say that our angle PQR plus angle angle QRP plus angle QPR will be equal to 180 degrees. That's the sum of interior angle of a triangle from plane geometry 1. So angle PQR, we don't know. That's why we are finding. Angle QRP is 35 degrees. And angle QPR is 48 degrees. That will be equal to 180 degrees. So our angle PQR plus 35 plus 48 will be 83, and to be equal to 180 degrees. Angle PQR will be equal to 180 degrees minus 83. So angle PQR, which they ask us to find, is nothing but 97 degrees. 180 minus 83 is 97. So we can say the angle here is 97 degrees. Now the next one, they say we should find angle QRS. Angle QRS, the angle here, the whole of this angle. But we already know this angle, PRS. So this angle plus this angle will give us the whole of that. Very easy. So we can say that. So this is our first one. Then the second one. Here. We can say our angle QRS, that's the whole of this angle, will be equal to the angle here. The angle here is QRP. So will be equal to angle QRP plus angle PRS plus angle PRS. So angle QRS, which they say we should find, will be equal to what's angle QRP. QRP is the angle here, which is 35 degrees. Then angle QRP, Q, and angle PRS. So PRS is 31. So plus 31. Then we can say that our angle QRS, 31 plus 35 plus 31 will be 66 degrees. I hope you get that. I hope you get that. We'll solve one more question on this so that you'll be abreast with the concepts. Okay, let's solve our last question for today. Please, before that, remember to subscribe to my YouTube channel and click on the notification bell so that anytime I post a video, you'll be the first to receive it. Now let's go to our question. They say in the diagram below, this diagram, BCDE is a circle with center A. And they say angle BED, this angle is 2y plus 10 degrees. And angle BAD is 5s minus 35. And angle BCD is 2s plus 40. And angle ADC is 40 degrees. And they say calculate the value of x and y. Then angle ABC, the angle here. Now let's see how we'll combine the properties that we have learned to solve this question. So let's look for a chord. Look at it, see. You can have a chord here. And the chord sustain an angle at the center of the circle. The same chord sustain an angle at the circumference. Remember that property? Now a chord again sustain an angle at the two opposite sides of the segment of a circle. So we use that properties to solve and find the value of x and y and this angle here. So we can say that twice of this angle here is equal to the angle here. So we say 2 times of angle BED, the angle here, will be equal to the angle here. will be equal to angle BAD. So 2 times, what's angle BAD? Angle BAD is 2y plus 10 and is equal to angle BAD. BAD is 5x minus 35. So when we expand this bracket, we get 4y plus 20 and it will be equal to 5x minus 35. When we group like terms by bringing the 5 here, we'll get negative 5x plus 4y equal to negative 35 minus 20. You can get negative 5x plus 4y equal to negative 55 equals to 1. Let's leave it there. Okay, so a chord again, look at it, the same chord. Sustain an angle at the two opposite sides of the circle. The sum of those angles is equal to 180 degrees. So we say angle BED plus angle BCD will be equal to 180 degrees. So we say angle BED plus angle BCD will be equal to 180 degrees. That's a chord. Sustain an angle at the two opposite sides of the segment of a circle. The sum of those angles should be equal to 180 degrees. Remember that property. So what's our angle BED? Angle BED is 2y plus 10. We say 2y plus 10. Then plus BCD. BCD is 2s plus 40. 2s plus 40 will be equal to 180 degrees. So what we have, we can group the variables. So we say 2x plus 2y plus 10 plus 40 will be equal to 180 degrees. So 2x plus 2y plus 50, 10 plus 40 is 50, will be equal to 180. So 2x plus 2y will be equal to 180 minus 50. So our 2x plus 2y will be equal to 130 degrees. Then we have our second equation. So now we can solve equation 1 and equation 2 simultaneously to get a value of x and y. So we have our two equations. Let's solve them simultaneously. I want to solve this by elimination. So I'll multiply equation 2 by 2. So what do I have? I'll get 4x plus 4y equal to 130 times 2 will be 260. This is equation 3. Then I have negative 5x plus 4y equal to negative 55, equation 1. Now subtract equation 1 from equation 3. So we say equation 3 minus equation 1. So 4x minus negative 5x will be 9x. 4y minus 4y will be 0. Then 260 minus negative 55 will be 315. Now we divide both sides by 9. Our s will be equal to 35 degrees. So now we find the value of s. Since we know the value of s, we substitute into any of the equation to get the value of y. So we find the value of s. We substitute into equation 2, which is 2x plus 2y equal to 130 to get a value of y. So we say 2 in place of s, we put 35 plus 2y will equal to 130. 2 times 35 is 70. So 70 plus 2y equal to 130. 2y will be equal to 130 minus 70. Our 2y will be equal to 60 degrees. So when we divide both sides by 2, y will be equal to 30 degrees. So now we know the value of x and y. So we are able to find the value of x and y. Now they ask us to find angle ABC. Angle ABC, the angle here. Look at it. The shape ABCD is a quadrilateral. It's having 4 sides. the sum of interior angle of all quadrilaterals is equal to 360 degrees. So when we add all these angles and equate it to 360 degrees, then we can find that. So we set the angle here. So we can say angle BAD plus angle BCD plus which angle? The angle here, that's ADC, angle ADC, then plus our angle ABC should be equal to 360 degrees. Should be equal to 360 degrees. Now, what's our angle BAD? BAD is 5x minus 35 plus what's our angle BCD? BCD is 2x plus 40. So 2x plus 40 plus what's angle ADC? ADC is 40 degrees. Then plus our angle ABC, which we don't know, should be equal to 360 degrees. Now let's group our like terms very well. So we have 5s plus 2s, then minus 35 plus 40 plus 40 plus angle ABC should be equal to 360 degrees. So 5s plus 2s is 7s. Now negative 35 plus 40 is 5. Then 5 plus 40 will be 45. Then plus angle ABC is equal to 360 degrees. So we know the value of s to be 35. So we can substitute now. So 7 times 35 plus angle plus the angle 45 plus angle ABC is equal to 360 degrees. So I'll multiply 7 by 35, we'll get 245 plus 45 plus angle ABC will be equal to 360 degrees. Now 245 plus 45 will be 290 plus angle ABC will be equal to 360 degrees. So angle ABC will be equal to 360 degrees minus 290 degrees. Therefore, our angle ABC is equal to 70 degrees. I hope you get that. Please, we'll end it here today. So in another video, we'll look at the other properties and their applications. Before you sign out, remember to subscribe to my YouTube channel and click on the notification bell so that if I post most of this, you'll be the first to receive it. Until we meet again.